Humanities. I welcome today's speaker, Dr. Subhendu Kumar Pradhan, an Associate Professor of Finance at VIT Business School, Vellore Institute of Technology, Vellore. He has more than 7 years of teaching and research experience as well. He had worked as a postdoctoral fellow in Department of Commerce at Indian Institute of Technology, Indore. He has completed MPhil and PhD in Management from Pondicherry Central University. He was awarded doctoral fellowship from Indian Council of Social Science in 2015. His area of research interest is information efficiency, corporate actions, and behavioral finance. He is an expert on structural equation modeling, applied finance, econometrics, bibliometric analysis, and meta-analysis. He has published more than 20 research papers in Web Science, ABDC category, and Scopus Index journals. He has presented more than 10 articles in national international conference. He is working as an editorial board member and review member for ABDC category and Scopus Index Journal. He is also acting as a resource person for various FDP and research methodologies, workshop, etc. I welcome you, sir. As
Thank
we
you,
gather
ma'am.
here for, as we gather here for the fifth day of virtual faculty development program on building up the insights of qualitative and quantitative aspects of research, it's my immense pleasure to welcome you all to this insightful discussion. Research, the cornerstone of academic advancement and societal progress. It is the quest of knowledge, pursuit of truth, and endeavor to unravel the mysteries that lies beneath the surface of our world. I look forward to an intellectually stimulating and rewarding learning experience. Thank you.
Thank you, Yohita, for setting the tone of today's session. Now, without further delay, hand over the platform to our esteemed speaker, Dr. Subhendra Kumar Pradhan. Sir, the stage is yours.
Thank you, sir. Thank you for giving me this opportunity to share my knowledge with the participant. Thank you all. So we'll start. Sir, shall we start? So I'll share my PPT.
Yes, sir. Yes, sir. We can, sir.
Sullivan sir, I think you have to make the sir as a co-host.
Yes, ma'am. Yes, ma'am. Sure, ma'am. Yes, ma'am.
Is it visible my PPT? Hello?
Yes,
Am
sir.
I-
Visible, sir. Yes, sir.
Okay. So very good evening. So today we'll discuss about the data analysis and interpretation of the outcome using the SPSS softwares. Okay. So can you tell me, participant, how many have knows about the SPSS softwares? Please raise your hand. And do you have software with you so that I can send the data and you can do hands-on practice? Hello, am I audible?
Yes, sir, you are audible.
Yes.
Audible. Participants, please respond to the resource person.
Do you have softwares? Hello, am I audible?
Yes, sir, you are audible only.
Okay. So that I can send my data set so that you can do some practice accordingly. Okay. You have the softwares. Otherwise, I am opening my softwares here. So in data analysis, when we are going for the data analysis, we have to understand about the type of variables. Okay, what kind of variables is required for the data analysis? So that is very important when we go for the data analysis. Okay. So I'll tell you, it is getting open. Is it visible, my screen?
Yes, sir.
Screen is visible. Okay. So here you look at this is the SPSS window. Okay. So I open this softwares. So here this is if you look at the bottom left side, the bottom here the data view. Okay. Here is the variable view. You can create the variable here, name of the variable. You can create the variable. Then what type of the variables, whether it is the numerical or a string variable or dot, whatever, or a date variable. So you can select that. Then width, then decimals, how many decimals is required for that particular data set. And the value you can give if that variable is related to the metric variable or ratio or interval variable or any Likert scale variable. So you have to give the value here. Okay. So like suppose I want to give one variable like gender. Gender is a categoric variable. Okay, non-metric. So you have to give here one for male and two for female. You can give any number to this. There is no logic to give for male and female. You can give any number because when we will create this variable, so we have to give the figure only numbers. Okay, then it will take non-figures also. It can be taken if you select here the type. Okay, so if you give the string, then if you type here the variable, it will take no issue. Then after that missing that it is not required, then you have to check here the measures. This is very important, whether that particular data is the nominal or scale variable. Okay, so nominal means we can say that those data which are categoric in nature. Okay, yeah, the male and female, it is a one category variable. So you have to give the nominal. Okay, so that is what you have to. Then similarly, so if you go to the age, so you can type here age. For example, how do you type? You have to type it like this. Okay, so when you type without first age, then it will be created. This variable is duplicate because we have already created. So you can put like as one, suppose I'll put, it will consider. Okay, so like this it will be created. So age is a like person's respondent age. So you have to create this variable. Okay, so like that I have created all the variables here. When we make the any kind of statistical analysis, so we have to take the assistant of any software for the analysis because in our data analysis our number of cases are very large. Okay, in my case, so we have taken 292 respondent for the analysis. So it is very difficult to calculate the manual or by hand or calculate it. So we need some software assistant to get the calculation. So similarly, so I have considered taken here the SPSS softwares to calculate this. Okay, so these are the variable. Okay, so this is the data. What data you have entered, so you have to get here. This is the variable. Okay, and these are the data point of each respondent. Okay, so this is the gender, this is the age, this is the investment, savings, investment avenue. So I have taken the variable, some variable for the data analysis. Okay, so am I right? So any question, any doubt? Hello, any doubt? Hello, any clarifications? Still no.
Sir,
Okay. Any
can we ask now, sir? Can we ask now itself?
Yes, you can ask me.
Sir, that age, sir, that age,
Hmm.
the measure, you put it in a scale, sir.
Yes, I have
For
put
example,
as a ratio variable. Yes.
investment, you put it in the, what's it,
In categoric, you can
Category.
convert, yes, you can convert this age into the categoric. It is also possible. How it is possible? We have one here. There is one. I'll tell you. There is one here. It is not visible.
So that one, okay, sir, but which will be the right, sir? Whether we have to put it in the
Yes,
ordinal?
no, yes, that is your question, sir. What I'm telling, it is depend upon the which kind of tools you are using for the analysis, which kind of statistical tools. Okay, suppose you are using to understand, suppose the age difference, okay, with respect to the male and female. In that case, the age need to be considered as a scale or ratio variable. Okay, if you want to understand the different age category of people means, so you have to convert this ratio into the category. Am I right?
Yes, sir.
Yes, it is depend upon what kind of outcome you require for the analysis. Okay, so based upon that, you have to select your statistical techniques for the analysis. Okay, but the age can be considered as the ratio form and can be considered also scale, the categoric form. Okay, that may be considered the ordinal scale. Okay,
Yes, sir. Thank you.
instead of nominal.
Yes, sir.
Am I clear?
Yes, sir. Clear, sir.
Okay, thank you. So these are the variables I have considered for the today analysis. So we will go to one by one analysis and we will let this. So this is what yes. We'll let this one. Yes, I have it here. Analysis. Yes, now it is visible. Yeah. So now we'll go to my. I have prepared some PPT. I'll take it down better. Okay, so now I have to take to my PPT. So today we will discuss about first the descriptive statistics, because before going to any kind of analysis, so we should know about the characteristics of the data, how the data looks like. So that is very important for each and every variable, whatever the variable you are considering, because unless until understand the characteristics or behavior of data, you cannot do any kind of analysis. That is very important. Okay, so descriptive statistics is nothing but it is all about the how many number of observations you are using for the analysis. Okay, that is important. And also you have to know if a particular data is metric data or scale data, we have to know about what is the mean or average of that particular data. You can come to know also what is the mean, median, mode, and what is the maximum value, minimum value, what is the range, what is the standard deviations, what is the variance, what is the scortosis and school. So these are very important to to understand the behavior of a particular variable. So if you once you understand this, then you can decide what kind of tools is required for my analysis, unless until understand these basics. Okay, so this we will do it. So then another thing is the hypothesis testing. So today what I am going to talk about the actually testing the we have to use some kind of tools or statistical techniques which help us to test the hypothesis. Okay, so these tests are actually parametric test. What I'm going to talk today, there are some non-parametric tests. Okay, So when we are formulating the hypothesis, we have to formulate based upon the actually objective of the study. Okay, so what the objective of the study is? So based upon that, you have to formulate the hypothesis to prove your objective. Okay, so when we will formulate the hypothesis, so we have to again choose the which kind of statistical tools is appropriate for testing that particular hypothesis. Okay, so when we test this, we have two assumptions. Okay, one is the null hypothesis, another is the alternative hypothesis. Okay, so null hypothesis, we have to frame it is actually whether it is a null or whether it is an alternative hypothesis. It is completely based upon the theory, what the basic theory this says. So based upon that, you have to formulate either the null or alternative hypothesis. So it is represent the null hypothesis h sub 0, alternative is sub h sub 1. Okay, so this what I taught, the parametric and non-parametric. If it is a parametric test, it is a actually the data should be drawn from the population and for the specific purpose, and the data should be normally distribution. So then we can use the parametric test. Okay, so that kind of a variable may be like interval or scale variables. So if your data set is like interval or ratio data, you can go for this parametric test. Okay, so these are the parametric test can be used for testing the hypothesis. One is the one sample t-test, independent sample t-test, paired sample t-test, ANOVA, correlations, regressions. So these are the tests can be used to test your hypothesis. Okay, so this test will do one by one. In addition to that, we will do the descriptive statistics. Okay, so let us go with a one sample t-test. Okay, so first let us do the descriptive statistics. Okay, so here when we'll go for the descriptive statistics, here this view you will get the SPSS interview. So here you will go to the top bar. Here you will find out file, edit, view, data, transform. If you want to take the assistant of if you want to convert a particular variable into a different category, you can take this assistant. Okay, this transform. And if you want to save here file, you go to here file save. If you want to edit something, then you can make it there. Here there are many features. Okay, if you'll work with this, and but here one icon is there, the analysis. So you have to use this one. Here all methods are available. Okay, so you can use this and you can do your analysis. Okay, so here if you come to here, there is one descriptive statistics. Okay, so here if you go to here, you will find out the frequency and the descriptive. Okay, these two are very important and others are also important, but today we will talk about this descriptive, or you can go with the frequency. Frequency means you can how a particular case is repeated. Okay, in your study, so that you can find out through the frequency. And a descriptive also you can get some descriptive statistics here. So let us go with this descriptive statistics, and you will find out one small box right hand side and left hand side. On empty side is there here. If you want to, you can select all the variables here. Okay, suppose I wanted to know this age. Okay, investment, savings. Okay, so if you want, you can just click and select and bring to this empty box side. Then you go to here options. If you go to the options, you will find out here so many uh, tested dispersions here and mean. If you want to know the what is the sum of that particular variable, what is the standard deviation, what is the minimum, maximum, variance range, you can get everything is here. What is the standard error mean, everything you will get it here. If you let us go with this, we can come to know. Then you will get your outcomes here. You will get your outcomes here. we got here outcomes. If you go to here, the age investment savings, you can come to know what is your numbers, what is the number of cases used here, and what is the minimum value, maximum value, what is the mean, what is the mean age. Okay, so mean is 34.1507. What is the investment? So what is the investment made by that particular, not particular, on an average investment? Okay, so this is what is the savings. So similarly, what is the standard deviation, skewness? So you will get all the informations here through the descriptive statistics. Okay, so am I clear now? Anybody want to ask any questions with this descriptive statistics? So when we do the descriptive statistics, mean is important here. Okay, mean. Mean you have to consider what is the maximum minimum, n is we have to consider. If you want to know about the reliability, then you have to take the assistant of the skewness and the scortosis, whether data is more reliable or not. It is depend upon the threshold value, like a plus to -2 in the range in between. So our also it is good. So based upon this, so we have to go for the further analysis. Okay, am I clear now? Am I clear? Shall I go to the next? Am I clear?
Yes, sir.
Okay, so come to here. First test is the one sample t-test. Okay, it is actually one of the parametric test we can use to understand about the mean of the population and mean of the sample. Okay, so what is the mean of population and what is the mean of the sample? Okay, so these two sample mean we will get here. Okay, so we have to understand that whether is there any difference between the sample mean and the mean of the populations. Okay, so somebody want to know that, then we can use this one sample t-test here. Okay, when we'll know this population mean, suppose you want to find out, though you must know the what is the population mean. Okay, so it should be known that value, then only you can compare with the sample mean, then you can, after that you can draw the results. Okay, so that is very, very important. And here the both variables should be actually metric variable. It may be the interval scale, or it may be the ratio, and both variables should be normally distributed, and the samples what the respondent you have collected from the population, that should be in a random and independently completed, then only this method is applicable. Okay, so what would be the null hypothesis? So you may consider the null hypothesis or alternative hypothesis, any one you can consider, but it is based upon the theory, what variable you have considered for your analysis. So you have to understand the what theory says. Okay, for example, so that you can understand, for example, if you consider a price and a demand, if I ask you what is the relationship between the price and demand, can you tell me? Anybody can tell me what is the demand and price relationship? What is the theory says?
So if the prices increases, the demand might be decreases, nor if
Decrease.
the
Oh, that is
prices.
economic. Yes, that economic theory says. Okay.
Yeah.
So that economic theory says there is an inverse relationship between the price and the demand. Okay. So here you have to formulate your hypothesis based upon the theory. What theory says means you have to tell the demand price influence the demand. Am I right? So that is what you have to consider here the alternative hypothesis. You cannot consider the price doesn't influence the demand like that. Okay, if price increases, so demand will decrease. So similarly, here you have to understand what the theory says. So based upon that, you have to formulate your hypothesis. When you formulate your hypothesis, it should be like this. There is no significant difference between the sample mean and population mean if you are considering the null hypothesis. If you are considering the alternative hypothesis, then you have to write there is a significant difference between the population mean and sample mean. Okay, so this is what, so like this you have to make assumptions, then you have to go for the analysis. So let us go to my SPSS subtitles. So here if you come to here, I have one variable mileage. Okay, this is the mileage actually I have considered. So what is the mileage of scooters or bikes? Okay, so if you put 1 liter petrol, so how many kilometer it will go? Okay, so we have made a survey. So we have collected some data from the respondent. So respondent, somebody says is going 50, somebody is telling 30, somebody is going 60, 25 like that. So they have given their opinions. Okay, so we have collected. So this is called the sample data. Okay, so we have to understand what is the populations test or population. What is a, if you put a 1 liter petrol in a bike, actually how on an average how much kilometer will go? So it may be go 50. Some company, particular brand company scooter, so they may say that my scooter will go per liter 50. Some brand also they demanded it is 60. So it may be vary. Okay, so particular company, suppose we will take a Honda, or we can take the TVS or any other scooter you can take. So if you'll consider, for example, the particular company, the demanding it is going 60 kilometers per liter, then we have to compare, that is the population mean, that is 60. Okay, so we have to compare with what is the actual performance. So actual performance, which one we have collected from the respondent, this is the data set. So we have to compare. Okay, so if you compare, you will come to know whether is there any significant difference between the mean of the populations and mean of the uh, samples. Okay, so how do you do that analysis? So you have to go to the analyze, then compare mean, then you have to go here one sample t-test. If you go to here, so you will come to you will get this into. Okay, so then you have to select the mileage. So this is the mileage variable. Okay, this is the mileage variable. Then after selecting this, then you have to check here, there is one test value. Okay, in test value you have to put the what is the population mean. Suppose we are making assumptions that 60 kilometers, then you have to put here 60 kilometers. If you want to test with the 50, you can put 50. If you want to put 60, it is depend upon what would be the population mean. So you have to put that. Then after that, so here you can check with the at what level of percentage you are going to test your results. So we are considering 95% of level of confidence. So then we can put okay. So we'll put okay. So if you put okay, you will get your outcomes. Okay, when you will get your outcome first, you will get the mean of this. What is the mileage? Okay, so then we'll look at this, the one sample t-test outcomes. Okay, so you have to look at what is the t-value, what is the degree of freedom, what is the significant. Here the significant is 0.000, means it is significant, means there is a significant difference between the mean of the mean of the population and mean of the samples. Okay, so there is a significant difference between the mileage, mean mileage of the scooter, okay, scooter, and the population mean, which one is the 60 we have considered here. Okay, so why it is significant? Because the significant value is less than 0.05. Okay, means we are considering the 95% level of confidence. Okay, so based upon that, you have to draw your result. Here, if you consider, suppose, the null hypothesis. Okay, if you consider the null hypothesis, then it would be rejected. Okay, means if you are considering like there is no significant difference between the mean of the sample, that is the mean of the scooter, and the population mean, that is 60. Okay, so means it would be rejected, and the alternative hypothesis will be accepted. That is, there is a significant difference between the mean of the scooter mileage and the population mean, that is 60. So here we have considered the test value, which is 60. Okay, this is the way you have to interpret. Okay, so any doubt, any clarifications about this one sample t-test? Any doubt, any clarification? Similarly, you can conduct the similar kind of study by using this one sample t-test. But we need the one, yes.
Sir,
Yes.
how you taken that the test value of 60, sir?
60, it is a depend, no, that is you have to consider based upon the performance, or you have to decide based upon your experience. Okay, suppose for example, if you will take you are considering a Maruti Suzuki car. Okay, so Maruti Suzuki car demanding, for example, whichever car you will buy from the Maruti Suzuki. So on an average, the mileage would be like a 20 kilometers, okay, per liters, or 15 kilometers, or 17 kilometers. Okay, so you have to consider as a, that one is the population mean. Am I right?
But
Okay.
what is the
Then-
purpose? We
then-
not, yes, yes, sir.
Yes,
What is the
then
need of that, sir? What is the use of taking that value? Whether we going to compare with anyone? Any
no,
value or-
yes, we are comparing that value with the respondent. We have made one survey. Suppose a company want to make a survey who have been purchased the Maruti Suzuki cars. What is the actual mileage of the Maruti Suzuki car? So they have made one survey. They have collected the respondent 100 riders. Okay, they have given their opinion, and they understand whether what the company is demanded, whether actually it is or not, or is there any difference? Am I
Yes.
right?
Yes, sir. Yes, sir. Understood. Sir. Yes.
So based upon that, so we have to decide.
Thank you.
Anybody else? Hello. So am I clear now? Am I right? So can I move to next?
Yes, sir. Yes, sir.
Okay. So another test is the independent sample t-test. This is very, very important test. Okay, so whenever we do the any kind of social science research, we used to use this test to understand the relationship between the two variables. Okay, so two variables are to understand between the two groups. Okay, so where this is also one kind of parametric test, and also be used for testing the hypothesis. Okay, so when we use this independent sample t-test, okay, so we have to follow some assumptions. Okay, so that assumptions is the data should be in actually normally distributed, and one variable. Okay, one variable should be categoric, and another variable should be metric or ratio form. Then only we can use the independent sample t-test. Okay, this independent sample t-test actually to find out or to compare the mean of the two group on a particular variable or in a particular dependent variable, which variable you are going to test. Okay, so for example, if you want to know about the what is the savings of the people. Okay, so savings of the people. So people may be two category. Okay, maybe two category, male or female. Somebody maybe say it is three category, maybe consider transgender also. But the independent sample t-test only used if the categoric variable are only in two subtype, then only we can use here. If it is categoric variable are having only the two subcategory. For example, gender. Gender is a one variable, categoric variable, and a nominal. And this gender having the two subcategory. One is the male, another is the female. Okay, so if you want to know what is the mean saving of the male, what is the female savings, we have to know. If you know this, what is the male savings, what is the female savings, then you can make comparison whether is there any difference between the mean of the savings with respect to the male and female. If there is no difference, then we can draw our conclusion based upon our significant result. So we have to, if you want to know this, what is the difference between whether there is a significant difference between the male and female with respect to the savings. So you can use this independent sample t-test generally. Okay, so what you have to do here, I will take one example so that you can understand at what situation you can use this independent sample t-test. Okay, so let us go to my data. If you go to my data here, here my data, there is a gender. Gender is a two category I have considered here. If it is three category, we cannot consider for the t-test. Okay, independent sample t-test. If it is only two category, then we can use the independent sample t-test. And another variable I will consider here savings. Savings I have given in the percentage form. Okay, percentage, it is in ratio form. Okay, so I have considered the savings and gender. Okay, so these two variable I have considered here, and I wanted to know about whether is there any significant difference between the savings of the male and the savings of the female. Okay, in that case, you can use the independent sample t-test. Okay, so here we have two category, and one is the metric variable, that is ratio, is a savings, and another variable is categoric variable, that is gender. Then you can use the independent sample t-test. Okay, so you will go to here, you can find out here independent sample t-test. Am I clear now? Am I clear? Any doubt, any clarifications? You can ask me. After that, I can proceed for analysis.
Clear, sir.
Hello?
It's clear, sir.
Am I clear? Okay, very good. So here, you come to here, when you go to this independent sample t-test, here the test variable is there. Okay, this test variable, you have to select which variable you are going to consider as a dependent, as a metric or ratios. Okay, so here I'm considering suppose savings. Okay, so I want to take the group variable. Group variable means we are considering the gender. Okay, so gender, when we consider, we have to define that variable. Okay, because in gender, if you look at here, there is 1 2 1 2. We do not know what is 1, what is a 2. So you have to define here. So 1, you have to put 1 2, and already it is defined here. I will show you where it is defined. When we have created the variable, we have defined it here. You come to here, you will come to know here. 1 is male, 2 is female. We have defined it already. So then, okay. So we'll go to again analysis. I can go to here. Come to here. This is what savings. Then go to the gender. Then give the define 1, 2. If it is suppose 4 category, we can put 1, 4 automatically. It will consider it. Okay. So now it is defined. Then after that, you have to select the option. We are going to test at 5% level of significance. Then not required to. Then put OK. So if we'll come to here, after test this, we'll get some output. Okay. So first we'll get the descriptive statistics. Okay. So this is the group statistics or descriptive statistics. We'll get like the male and female numbers. So how many males are there? How many males in our respondent? 172 males. And how many females? 120 females in our survey. Total we have 292. Okay, so this is the mean. What is the mean? Mean of savings for male, it is 28.51 and 54.82 is a saving percentage for female. This is nothing but on an average. So if you look at this figure, can you tell me, is there any difference? 28 and 54. Is there any difference? If you, by looking at the group statistics, is it?
Yes, sir, there is a difference.
There is a difference. Okay, but we do not know whether it is a statistically difference or not.
Yes, sir.
That's why we are applying the independent sample t-test. So we can draw the outcomes through the group statistics, no doubt, but we don't have any evidence to say there is a difference. So for that, we have used the independent sample t-test. Here, come to here, we have the independent sample t-test. Here, so many results are there. So we have to look at here, equal variance assumed, equal variance not assumed. And here 11 test equality of variance. So here we have t-test. So as we have done the t-test, here t value are there, degree of freedom and their corresponding significant value here. So here, so we have to which t value we have to consider, as it is 2 t values. Which one? It is completely based upon the 11 statistics. If 11 statistics is significant, suppose, means the both the variance of both group are equal or homogeneous. If it is insignificant, if it is not significant, okay, if it is not significant, then we can say the both variance for both group are not equal. Okay, so here so we need to understand here, if they are significant, both variants are not equal. If it is insignificant, then we can say variance for the both group are equal. Okay, so here as it is significant, so you have to consider the equal variance not assumed. Because why? The 11 statistics is significant. It is less than 0.05 means you have to consider the t value of the equal variance not assumed, means you have to consider this minus 11.415 and their corresponding significant value, and this value is actually significant. If it is significant, then we have to say that the savings of the male is different from the savings of female. Okay, so because there is a difference between male and female with respect to the savings. So here, can you tell me null hypothesis is accepted or rejected? What is the null hypothesis we have to consider here? Anybody?
There is no significant difference between population mean and sample mean.
Here no population and sample, all are the sample
sorry.
mean. Yes, sample mean. You have to
Sorry,
tell
sorry.
there is no significant difference between the savings of male and
Savings of
savings
male
of
and savings
female.
of female.
Yes,
sir.
yes, that is the null hypothesis. And alternative is there is a difference. So based upon our result, whether we will accept or reject the null,
We will accept that.
we have to accept or reject the null.
The null hypothesis is rejected, sir.
Yes, we have to reject the null. There is a difference. Am I right?
Yes,
There
sir.
is a difference. Am I clear, sir?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Okay, thank you. So like that, you have to do it. So similarly, if you have a categoric variable in having two subcategoric and one metric variable or ratio or interval scale variable, so you can use the independent sample t-test. Okay, so and you can formulate your hypothesis. So formulation of your hypothesis actually based upon the theory. Theory sometimes also be apply some logic also to identify the actual which one would be the more appropriate hypothesis, either alternative or um, null hypothesis. Okay, so if you are not identifying, suppose you are not able to understand the theory, you can consider the null always. That is also correct, but you have to always give the priority to the theory. Okay, then after that you can formulate the hypothesis. So this is all about the independent sample t-test. Am I clear now? Then
Sir,
go to,
excuse me.
yes. Any
Sir, I
question?
have got only one doubt. Can I?
Yes. Yes,
Sir,
yes.
sir, as you said, independent sample t-test used to compare the mean score of two groups or
Yes, yes, two
opinions,
group.
as you
Yes,
said.
yes, yes.
Say, for example, if the in gender, if we have one more gender, that is third gender, can't we
Yes.
apply this independent sample t-test?
Yes, we can apply, but in that case, we have another test. Why you will use the independent sample t-test? Because it is it will compare the two group. If you use even it is a three group, you can use independent sample t-test, but you will get the number of outcome. They will compare with the first male with the transgender, then male with the female, then again it will be compare female with the transgender. We will get the number of outcomes. Am I right?
Okay,
So
sir.
it would be more complicated. In that case, you have to use the analysis of variance. There is another options. You have suppose three subcategory in a grouping variable. Am I right?
Okay, sir. Okay, sir.
You can use. I'm coming to that test also. Am I
Okay.
right?
Okay, sir. Thank you.
Okay, thank you. So let us go to another test. This is also very, very important. Suppose you are doing some experiment. So can I take 2 minutes, sir? Hello? Hello? I'm taking 2 minutes.
Yes, sir.
Yes, sir.
Yes.
Yes, sir. Yeah, dear respondent, we will join as soon as possible. We got a call. That's it. We'll join. Few 1 minute.
Hello, am I audible?
Yes,
Hello,
sir. You
am
are
I
audible.
audible? Okay,
Yes, sir.
sorry.
Yes, sir.
Sir,
So, yes,
regarding the independent sample test,
yes,
in our questionnaire, we have three
yes,
options sir, for gender, male,
yes.
female, and then transgender.
Ha.
So once our data collection process is over, we find there is no anyone opted a transgender. There is no respondent belonging to
Yes,
transgender.
yes.
There is no option of allocating third category. That is A,
Okay,
that is a
okay.
male, female, and then transgender. Can you omit the
Ha.
transgender and we can go for male one and female two, so that we can opt, so that we can apply the independent sample test?
Yes. Suppose, for example, you have asked one question, very good questions. Suppose you have kept one category in one subcategory in a categoric variable. If nobody respondent are not there or there is no response value, so while you will do the analysis at that time, you can remove it. You can remove it from your study. So no problem. And suppose there is only one respondent, also you can consider, but you have to test, you have to take a robust decisions when we do, or you will delete one items from your data set. So you have to find out the cause and effect, then only you can delete. If there is no response, then you can remove data and you can do independent sample data, no doubt about it.
Thank you, sir. Thank you.
Okay. So let us come to the another test, which is a also important test. We do this test while we do any kind of experiment or any, if you want to know any effect or cause. So you can use the test. It is called paired sample t test. Okay. This test is like one statistical techniques you can use to understand about the population mean and sample mean. If you want to find out, or if you want to know the relations, or if you want to understand what is the effect of giving the treatment, okay, you can compare with the previous results with the current results, okay, by comparing this. So otherwise you can compare the population mean with the sample mean. Okay, what is your standard and what is the actual performance? Or you can consider, for example, I can make you understand by giving one example. For example is suppose you are conducting a faculty development program. Okay, so there are many participants. If you want to know what is the effectiveness of conducting this FDP program, so you have conducted a test before conducting the FDP program, the first day of FDP program. Who are the participants? You have conducted a test about the which subject you are delivered. So yeah, they have some respondent secured good mark, or some respondent may secured less mark, whatever it is. So then after conducting this FDP, then you have again you have conducted another test. Okay, so they have secured some mark. Then you can compare these two mark. Okay, before conducting the FDP, what their score, And after conducting the FDP, what is their score? You can compare these two score, whether is there any difference. If is there any difference, then which kind of impact, or positive or negative, whether the mark score is improved or not. So to compare this two outcomes, you can use this paired sample t-test. Okay, so similarly you can keep like the hypothesis there is no significant difference between the mean of two variables, or population mean and sample mean. You can keep, and or you can make like the relations, and alternative hypothesis you can put there is a significant difference. Okay, so in that case, which kind of variables you have to consider? Actually, you have to consider the two variable are actually the interval scale or ratio, or ordinary scale also you can consider it. Okay, so in case of a nominal, it is not required. You cannot use this paired sample t-test. It basically be used if your data is ratio format. Okay, so let us go to my data set. You can understand about the analysis. Okay, so let us go to here. Let us go to here. Okay, so come to here. Which test I have to do here? You come to here. There is a before training and after training. So this we have conducted one test before giving the training to the people. What is their score? We came to know by making one survey. So we have kept here 292 respondent cases, and these are the score. And after giving training them, so what is their score? So this is their score. Okay, so we are going to compare these two score, whether is there any significant difference. If there is a significant difference, so we can say that there is some improvement, or there is some effect of conducting this training or giving training, so that their performance has increased, their performance have been increasing. So in that way we can conclude. Okay, let us go to this our here paired sample t-test. If you go to how do you get this, you just go analyze, compare mean, then paired sample t-test, then you have to select the here there is a pair one, variable 2. Variable 1 you can put the before training, what is their score, and you can put the next variable after training their score. Then options, you just select a 95%. Okay, you can also change here 99% if you want. You can change also. It is up to us, the researchers. Okay, then you can get the outcomes. You come to here, the before training and after training, the correlations. If you want to know what is the correlations, their correlation is they say that their improvement and decreasing, increasing, their correlations is negative and insignificant, no much changes. Okay, if you come to the paired sample t-test, if you look at their t value and significant value. Okay, can you tell me here, is there any significant difference giving the training? Anybody can tell me? By looking at the t value and significant value here. Anybody? If you come to here, this is the mean of this score. Here, if you look at this t value and significant value, it is less than 0.05, means significant. There is a significant difference between the mean of before training score and after training score. There is a significant difference. Okay, so means we can conclude that there is some effectiveness of giving the training to the people. so that they can increase their productivity or they can increase their performance through the training. So if you want to know about this, how your training is effectively work, so you can apply such kind of test to understand. Okay, so similarly, so similar kind of study, and this study also helpful for the medical science. They and the study which are experimental based. So such kind of study can be useful for this test. This test can be applied such kind of study. Okay, so experimental based, treatment based study. Similarly, if you are conducting any new program, suppose you are launching, so you can also apply such kind of study after getting their opinions before conducting the program. What is their opinion about a particular subject? After training, what is their opinion about the subject? What is their learning before training? What is their learning outcomes? Okay, so after learning, what is their outcomes, what is their difference, so you can also measure through this test. Am I clear now? Any doubt, any questions?
Yes, sir.
I'm in right directions?
Yes, sir.
Okay.
Sir,
Yes.
as you
Yes,
mentioned,
yes, you can go on.
before and after cases, we can apply parity test, no, sir?
Yes, sir. Yes, sir. Yes,
Sir,
sir.
any other criteria or any other time when we can go for it, sir? Only before and after analysis?
Not before and after. Suppose you are doing some experimental research also, you can apply this treatment. How a doctor's treatment is effectively work or medicines. Okay, so such kind of research you can in such kind of research you can apply this in this study. Okay, as it in social science, it is used mostly this test. Okay, so we can find out through this test.
Okay. Thank you.
What is the difference?
Yes, sir.
Okay, so then next is next test is analysis of variance. Okay, it is similar to the independent sample t test. Okay, so analysis of variance is actually similar to the independent sample t test. In independent sample t test, the categoric variable is having only the two subcategory, but here analysis of variance, you can use more than two categoric variable, and the other variable should be remain same, like the ratio or interval scales. Okay, so it is also called extension of the t test and z test. Okay, so this is a called also another way of doing like the one way ANOVA. Okay, one way ANOVA, two way ANOVA. So one way ANOVA means we are considering only the one independent variable in our model. If you are considering two way ANOVA means two independent variable in our model. Okay, so like that. So this test, when we are going to when we will use this, so if the categoric variable is having the more than three category, three subcategory, and another is the one dependent variable. Okay, that should be ratio or interval scale, and this variable generally be used to know the difference between the groups. Okay, that group should be more than two groups. Okay, with respect to a test variable, which variable you are going to test. Okay, like the dependent variables. For example, if you will talk about the, we'll take one example, uh, the college professors. So professors designations are three: assistant professor, associate professors, and another is the assistant, associate, and professors. Okay, so three category of professors, okay, working in the university or colleges. If you want to understand their working loads or hours of working loads, or if you understand their total credit loads, okay, subject loads. So if you want to understand whether there is any significant difference between the assistant professor, associate professors, and professors with respect to their working load. Okay, so you can use this test, analysis of variance, because here the categories are 3 subcategories. Okay, in a particular category variable which we are considering as independent variable. Okay, so it's having the 3 subcategories. Okay, and another is the metric variable, the working hours or working load we can consider. Okay, so in that case we can use the analysis of variance. Okay, so you can come to understand here by looking at this. Okay, so I have taken what is the mean difference between the three groups. Okay, so here there is a distributions, there are 3 distributions. If you look at, if you say that what is the mean of particular groups, so that may be come here. Okay, if you ask what is the mean of the each groups, mean of each group, mean of first group, mean of second group, mean of, so it may be different. Sometimes it may be equal. Suppose it is equal, it is not required to use the analysis of variance. If it is not equal, it is necessary to use the analysis of variance to understand whether the variance are equal or variance are not equal, whether is there any significant. If you look at their mean in this picture, can you find out the mean of each groups are different or same? Are different. The first group mean is different. This group mean different. These are the different. Hello? Yes? Yes? So that's why it is required to test the analysis of variance. You have to apply the analysis of variance to understand. So when we will understand the analysis of variance, it's calculated with the help of the F statistics. It is nothing but the variance between the group, variance within the group. Okay. So variance between the group means what is the variance of between what is the how the group A differs from the group B and how the group A differs from the group C. Okay, so like that, and within the group means how the cases are different each other within the group. Am I right? So that is how a particular case response is differ from the another case, how their variance. Okay, so in analysis of variance, we'll consider the variance within the group and variance between the groups for the calculations. So their assumptions is like the independent sample t-test. So the test variable should be normally distributed. Sample, which is sample will draw from the population should be independently. There should not be any conditions. And the variance of populations are equal, and samples should be selected randomly. Okay, so that is what we need to satisfy under these assumptions. Then you can apply this ANOVA, analysis of variance. So what would be the null hypothesis or alternative? So the similar way you can write there is no significant difference between the variable. So somebody says that can I write there is no relation, there is a relation. Can you write? No, you cannot write. Because this ANOVA family or the D family, actually it is used only to understand the difference. It is a compare between the two groups or two variables to understand the difference. So due to that, we have to write here appropriately there is a difference or there is no difference. You cannot write the relationship here. Okay, there are some case you can write. Okay, some case you can write, but if that variable is like the metric variable or ratio forms, okay, but generally it is not required. This is the postdoc analysis, so that is a part of this analysis of variance. We'll go through it. Okay, let us go to our data. Are you getting it? Are you getting it? Hello? Any doubt, any clarification about the ANOVA? So that I will make
Sir,
yes.
in that PowerPoint PPT, the last option you mentioned that simple random sample.
Okay.
Is it sampling, sir, or what?
Yeah, random sampling technique.
Yes. If our data collection is under the stratified random,
Yes.
we can't apply this method, sir.
Yes, you can apply this. Yes.
But you
It should not be under some conditions. Am I right? It should be collected independently and randomly. Okay.
Stratified random sample also we can apply.
Yes. It is a random sampling technique.
Yes. Okay, sir.
Am I right?
Yes.
It is a divided some category. Okay.
Yes.
Clustering, stratified sampling technique. Okay, these are
Yes,
these are coming under the all probability sampling.
Yes.
Okay. Okay, so next we will go to the analysis. So before going to the analysis, we will understand some variables which are having the categoric, and we have some variables like what is called the metric variable or ratio variable. Okay, so here I have kept one variable is the awareness. Okay, so I have made one survey about the whether the people know about the awareness about the investment in the stock market or a financial market, a derivative market, equity market, cryptos market. So I have made one survey to understand those who are investing in the stock market or any market, okay, financial market, whether they are actually aware about that or not. Then we have find out some score, then a score I have converted into the scale format. Okay, so here we have the awareness. Okay, then we have another variables, the categoric variable investment avenues. So different kind of investment. Okay, so if you look at this investment avenues, I have considered the stock market, crypto market, mutual fund, bond market, bond debenture, fixed deposit. These are the related to the fixed interest. Okay, and a small saving investment scheme. So I have taken the 5 different category of investment avenues. The people have responded to this. So I have considered as this is a categoric variable here. Okay. Then I have considered already I told about this. This is not required because I have considered the ratio for this ratio or scale. So we have to go to the analyze, then analyze, then compare mean, then here one way ANOVA, because we are going to consider only the one independent variable in our model. Okay, so if you go to here, so there is a box here, empty box right hand side. So you have to select or you can drag the variable and put here a dependent list. Okay, so here I am going to the test variable awareness. Okay, awareness, and the factor, what is the factor is nothing but the investment avenues. Okay, I'm putting here. Then I'm not clicking anywhere, just put okay. Let us go to okay, and we will get our results. Now we got our results here. This is our ANOVA results. In ANOVA results, you will get the between group sum of square between groups. Between groups means how many groups we have. Okay, so we have like the different investment avenues, stock market, the different group. Okay, stock market, cryptos, mutual fund, debentures. Okay, so cryptos, so we have different groups. So this is the sum of square of that, and within the groups, within a particular groups, this is what the outcomes. This is the total. This is the degree of freedom, is nothing but the k minus 1. K means what is the number of a group, minus 1, and this is the within the group means we need to understand what is the number of cases or respondent in minus 1. Okay, the mean square is nothing but the sum of square divided by the degree of freedom. You will get the mean square between the group and mean square between the within the group, and this is the F statistics, and this is the significant value. If you look at this significant value, it is a statistically significant or not? Can you tell me, anyone?
Significance.
Significant. Okay, it is significant. Oh, can you tell me how it is? Why you say it is significant?
That's below 0.05.
Yes, below 0.05. Even if you take also 99% also 0.01% also, it is uh, less than 1%. Okay, so it is also significant at a 99% level of confidence. So so means, can you tell me here, the null hypothesis is accepted or rejected? It is rejected. The alternative is accepted. So in an alternative, if it is accepted, means what conclusion will it draw? Sir, can you tell me? What conclusion will draw here?
Yes, sir. 1 second. That's fine. See, awareness and investment of news.
Yes. So we can draw the conclusion like this: the different category, those who are investing the stock market, cryptos, or we can say the bonds, debentures, their awareness are different. Okay, means the awareness of the investors who are investing in the stock market is different from the awareness of the investors who are investing in the cryptos. Okay, they are having the different awareness level. Am I right? They have no equal awareness. Am I right? Am
Yes,
I right?
Yes, sir.
So that is what we will draw the conclusions. Okay, so means the awareness level is a significant difference between the different investors. Okay, so investors in the stock market, investors in the cryptos, all the things. Okay, so this is what the conclusions. So if we will take the some other variable, I have also some other variable. If we'll consider, we can come to know and we can understand the better if we'll consider some other variable. Let us take some other variable here. I'll consider some other variable.
Sir, second.
Yes, you can.
Sir, previous case you took the dependent variable as awareness. Another one, the factor you put that
factor awareness. That is the grouping variable.
Yes, sir. Yes, sir.
Category. Yes.
Yes, sir. Can we use investment avenue as a dependent? Is it possible, sir?
Yes, you can take the dependent, but it should be in metric form. But our is a category. You cannot consider here. Because you can consider investment avenue in the term of investment. The value you can consider as it is a category, you cannot consider as dependent. You have to consider as always the independent. But some analysis are there. You can consider if the investment avenue is in binary form or category, you can consider as a dependent variable if you use the multi-nominal logistic regressions. Am I right?
Yes, sir.
Yes, multi-nominal logistic regressions. You can use the categoric variable as a dependent.
Categorical variable as a dependent.
Dependent. There are the logistic, there are different type. One is the binary logistic. If your categoric variable are 0, 1.
Yes.
Okay, so in that case, you can use the binary logistics. If you suppose ordinal logistics, suppose your category variable are in ordinal form, so you can use the ordinal logistics, and multi-nominal logistic you can use if your variable are categoric more than 3. Sorry, more than 2, not 3, more than 2. Okay,
yes.
That's dependent. Am I clear now?
Yes, sir. Yes.
Sir, once again.
Yes.
So in the awareness, shall we give the values like aware or not aware, or will it
Yes,
make sense?
yes, you can keep But if you give 0, 1, it would be a categoric variable, sir. It cannot be considered as a scale variable.
Okay.
Award, not award. Okay.
Okay, sir.
Okay. So in that case, you cannot consider awareness as a dependent here. Am I right? So that's why I told you before taking this analysis, I told you my awareness is calculated based upon by asking the 15 different questions. Then I've converted into the score. Then that score converted into the again scale.
Okay.
That's my point. So if the awareness is 0, 1, it may be the binary. So you can, instead of using the analysis of variance, you can use the binary logistic regression.
Yeah. Yes.
Am I clear?
Yes, sir. Yes, sir. Yes. Thank you.
Okay. So any doubt, any clarifications? Then we will go to the same analysis. We will go to, again, we will run this. I want to tell you something more about this. Let us go to the again analysis of variance. There is a post hoc analysis. If you want to know how the groups are different from each other, you can come to know by Duncan analysis. Here there are many tests. Okay, you can use to understand how the groups are different each other with respect to the awareness. So you can come to know through this Duncan. If you go to this, if you click here, okay, so you can come to know here. This is another table, you will get it here. This is the table you will get. First table, the result will be remain same, but here, this is the awareness. Are you getting this? If you come to know, the mean of the stocks to stock market is 2. And if you look at this table, the mutual fund, those who are investing in the mutual fund, actually they are highly aware. Am I right? Are you getting? Hello? Am I audible?
Yes, sir. Yes, sir.
Yes. So there are 3 subset. Those who are investing in the mutual fund, they are highly aware. This is 3.8889. If the second subset is there, so it is coming under this category. So this category, people, those who are investing in this cryptos, bonds, they are moderate, and a stock market who are in, they are lower aware. Okay. So means they are means the mutual fund is those who are investors are investing the mutual fund, they are highly influenced the awareness. Am I right? This is the lower level, this is the higher level, these are the moderate level. So you can throw this Duncan, you can make the comparison the group with respect to the level of awareness. Am I right? So this is also another way you can represent after understanding if there is a difference, then how it is difference with respect to the different group. So you can come to know from this Duncan. Am I right? Am I clear now?
Yes, sir. Yes, sir. Yes, sir. Please proceed.
Okay. So come to then we have to go to the correlations. So everybody might have know about the correlations. Can you tell me what is correlations, sir? So this is also another type of parametric test we can use to understand the relationship between the 2 variables. Am I right? Hello?
Yes, sir. Yes, sir. Yes, sir.
This is we can use the correlations actually to understand between the relationship between the 2 variables. Okay, that variable may be categoric variable, that may be non-category or ranked variables. Okay, you can find out the correlations. If the 2 variables are actually 2 variables are suppose ratio or in a interval scale, we can use the Pearson coefficient of correlations. If the variables are in a ranked form or ordinal form, so you can use the Spearman rank correlations. Okay, so if we'll go to, I'm just overviewing this. Okay, suppose I want to know the what is the relationship between the height and weight of a person's. Okay, those who are having the height, so they are high weight or not. So if you want, you can understand through applying this. whether they are moving in the same directions or opposite direction or no change. Okay, so the relationship may be in the three different. It may be the positive or it may be the negative. Suppose the change of the both variable, okay, in the same directions, then we can say it is a positive. If the changes of the both variables are opposite directions, we can say it is a negative. Or if there is no change of the both variables, we can say that there is no relations. Okay, similarly, the price demand. Okay, already I talked about this individual stock price and market index. Suppose you want to understand about the Infosys stock price with you are comparing, suppose the Sensex, okay, market index price, how the uh, Infosys stock price changes according to the market price changes or Sensex price changes. So whether it is following or not. In that case, you can apply this correlation can be applied to social science research. It can be applied the where we can apply the science, we can apply the psychological research, economy, finance, we can apply anywhere. The correlation is must. If you understand the correlation, then you can apply some higher kind of statistical technique to understand the in-depth, okay, relationships. Okay, so correlation is very basic and it can be represented by the small r. Okay, so and the correlations value range in between the -1 and +1. If it is a -1, there is a perfect correlations. If for example, suppose 10% change in a variable, the same 10% will be change in the other variable, then it can be said a perfect correlations. That may be the positive, that may be the negative. If the same percentage change in the variable, okay, in the same direction, so we can say it is a perfect. If it is opposite direction, we can say it is negative. Okay, so this is all about the correlation coefficient is called the small r. It is represented by the small r. Okay, so these are the positive, and if you come to here, the correlations value, if you bring into the pictorial form, you can come to understand the relationship between the two variable. Okay, if the correlations value is 0, so you will get the variable, the relationship between the two variable like this. Okay, if you come to the 70%, it would be like this. Okay, so if you come to the 99%, then the relationship between the two variable would be linear trend. Okay, linear trend. This is called the linear relations. Okay, so if it is like the scattered form, it is the scattered. So we can say the correlationship between the two variable is less. Am I right? So this is what the variable. Okay, so this is another pictorial form of the relationship correlation value. Okay, for your understanding, I have given you, this is there are the different method you can use for understanding the correlations. This is the scattered, the Pearson coefficient correlations, the rank correlation, and product moment or covariance. So based upon some basic parameter we can use to calculate the correlations by taking the help of the covariance and the standard deviations. So that can help us to understand. So let us take some exam, and another thing is how the hypothesis you will write here. That is the most important, because when you make a test to understand the relationship between the two variables, you have to formulate the hypothesis, which is very important. Here you can write the hypothesis like this. There is a relationship between the two variables. Okay, so alternative hypothesis. You can write also null hypothesis. There is no relationship between the two variables. Okay, that is null hypothesis. So whether you will formulate the null or alternative, it is completely based upon the theories. Okay, so what the theory says, if they say that there is a relationship between the price and the demand, so you have to write only the alternative hypothesis. Suppose you are following the economic theory here. Okay, so price and the demand, suppose you are going to conduct a study. So you have to write here only the alternative. If you write the null, it is not wrong, but you are the against the rule or against the theory. Okay, you are diverting the theory. Okay, so you have to accept the theory. Okay, so that is very important in the study while we are formulating the hypothesis. So you have to consider or you have to give priority to the theory. Okay, while formulating the hypothesis. So this is we have to make this. Then let us go to what I told you, the calculation coefficient of correlations. You can use the parameters, you can calculate the correlation covariance x and y, x variable and y variable during standard index. So these are the formula you can apply and you can get the answer. So I'm not talking about this. So let us go how to do the correlations analysis in the SPSS by using the variables. And when we are using the calculation coefficient of correlation, what would be the variable type? Okay, let us go to my one data set we have here, correlations data set. So come to here, we have the data set. I'll go to the data set data view. If we go to the data view, we have here the income, savings, investment. Okay, we have these variables and we have the other variable also we have. For example, we'll take the advertisement in the sales. Can you tell me what is the theory of advertisement in the sales? Anybody in the marketing here? Marketing persons? What is the theory of advertisement and sales? Hello? Is there any relations?
Sales depends on the effective advertisement.
Yes. So there is some theory. So what is the what is according to you, what is the relationship here? Is there any relation?
Sir, I would say it's a direct relationship. If you increase
Cause and
advertisement
effect
expenses,
relationship.
Yes,
accordingly,
very good.
sales also will get increased.
Yes, very good. It is a direct relationship. It is a positive relationship.
Cause and effect relationship.
Effective relationship. Okay, very good, ma'am. Very nice. So, so if it is a positive, we said, okay, we said our theory says, but we have to test with the data. Am I right? So we have the advertisement and sales, we have to test it. So let us go to the correlate, then bivariate, then we have to test. We have to test
Sir, can I ask you a doubt, sir? Now itself?
Yes.
This correlation will be calculated only two variables. Two variables should be in the in terms of like statistics, like advertisement expenses and the sales, profit and the sales. Only for these kind
only two combinations, two variables. We can keep in our model n number of variables. When we calculate the correlation, it would be calculated by combining the two variables. Okay, all the time, two combinations. Okay. So here suppose we have advertisement, sales and profit. Also you can apply the correlations, but when we are going to get the correlation value, it is the value for the two variables, combination of two variables. Okay, but we can make comparison how the sales whether having the highly correlated with the advertisement or not. We can understand that through this correlations value and with their directions, whether it is a positive or negative. So we can come to know through these correlations. Okay, so if you understand this relationship, then you can go for the advanced model. Okay, so let us go to this correlate, bivariate. Then we have to go to the sales we have in lakhs. And two variable, you remember, when we are using the calculation coefficient of correlations, the variable should be in a ratio form. I'll tell you here, if you look at these two variable, advertisement and sales. So sales in a lakhs and this is the advertisement. Okay, so this advertisement and the sales are in the ratio form. So we can use the calculation. Here we have the calculations, spearman and candle test. So we have these three, so we can use these calculations. Then options we can go the same thing. If you wanted to know the mean and standard deviations, mean the group statistics, you can apply if you need it. If you don't need, then it is not required. Suppose somebody want what is the average sales, what is the average advertisement cost the yearly, so you can come to know. And if there is a relations, then you can spend more on the advertisement. Okay, so that you can increase your sales. Okay, let us go to here. We can put okay. So come to here. Now you will get your outcomes, the correlation matrix table here. Here the sales in lakhs and advertisement cost in 1,000. Okay. So here, if you look at this, can you tell me here what is the correlation value here in this table? The Spearman correlation is 0.780. What it indicates? Anybody else? Hello.
This relation, sir.
Yes. It is 0.780.
There is relationship between advertisement and sales.
There is a relation. That relationship is strong. Am I right? And we have to look at their significant value. In significant value, is it less than 0.05? Is it 0.05? Yes, it is a significant. It is less than 0.05. So means we can say there is a relationship between the sales and advertisement. And what kind of relationship? No, the relationship is positive here. If we increase the spending in advertisement, definitely your sale will increase because there is a positive relation, and that is the strong. If suppose 10% change in your advertisement, almost the 10% the sales will increase because it is the 0.78. It is not exact perfect positive, but it is closer. It is 0.78. It is somewhat, it's a high positive correlations. Okay, so you can draw, suppose here a correlation value is 0.9. So you can say it is a strong, almost perfect. Okay, you can say this. So this is the relationship between the sales and advertisement. If we go to the other test also, other variables, we can also come to know what about this. We'll remove this two variable. Let us take other variable. We can understand about this three. Yes. I have taken the three important variable: income, savings, and investment. What are the relationship? Can you tell me what is the relationship between the investment and savings? What is the relationship between investment and savings? If you will save more, you will invest more. Am I right? That is in general.
Yes, 0.73.
Am I correct?
Yes, sir. Yes, sir.
Yes. Similarly, if you will income, if you will earn more, you will save more. Also, you can invest more. Am I right? All are having the positive correlations.
Yes.
So what we understand in general, if you by test also, it is showing the same relation. If you come to the income with the savings, it is the positive correlations. If we compare the income with the investment, it is also 0.61. This is the pair. Income with the income, it is 1. Because why? It is a perfect positive. Always it would be 1. And savings, if you cross income with savings, it is 0.53. Income with the investment, it is this much. So similarly, the other comparisons, savings with income 0.53, savings with this is the correlation matrix. Okay, so accordingly you can calculate it like this. So any doubt, any clarification about the correlations?
Sir, as you said, the value like 0.730, it's makes a strong relationship between the variables.
It is, we cannot say high strong, but somewhat strong. If
Somewhat
it is a
strong.
0.53 means, it is above 0.53 means it is a high correlations. Okay.
So what is the okay, sir? So what is the least one and what's the
least means if it is closer to like 1%. Am I right? Below 5%, we can say it is weak. It is above, we can say somewhat it's a good correlations, high correlations. Okay. Suppose only 1%. Am I right? Am I right? Suppose the relationship between two variables are income and investment 0.001.
okay.
Or am I right? So it is less. Suppose 1%. Suppose 0.01 means only 10%. Am I right?
Yes.
So
yes.
it is a 1%, 10%. Suppose it is 50%, above 50%. It is good correlations. If it is only 30%, am I right? It is less correlation. Am I right?
Yeah. Yes.
So if you will spend more on the advertisement, it is no worth. Okay, for the sellings. Am I right?
Yes.
Your cost of productions or cost of product will be high because of more advertising. Am I right?
Yes.
So that is what we need to understand these correlations. Okay.
Okay.
So next.
Sir, 1 second, sir.
Yes.
Correlation can be calculated only for quantitative two terms, like a sales profit. If it is a qualitative terms like awareness level and investment decisions, can
Yes.
we calculate correlation?
We can also calculate correlations, but we need to convert the data into the scale form. Okay. So 5-point Likert scale, you have to keep the awareness. So what I have kept the awareness here. We have kept one variable, the awareness. We can use because it is a interval scales. So you can use correlations. But for categoric, you cannot use it. Am I right? So here, awareness, you can use here because mine is the awareness you can use. Suppose you are one maybe the strongly disagree, two maybe it is called the disagree, three maybe the neutral, okay, four is the agree, five is the strong agree. You can use this. Am I right? So you can use. And there is another also Spearman rank also you can use. So if your data is ranked form data, you can also use. Am I right? So any doubt, any clarifications? Any doubt, any clarifications?
Clear, sir. You can proceed.
Okay, so now we can go to with the regressions. It is very, very important. Once you understand about the relationship between the two variable, we can understand what extent the influence the one variable to the other, what extent a particular variable influence the other or other variable, how it explain the other variable. Okay, so we can to know this, we can apply the regressions analysis. Means here when you apply the regressions, you can apply the regression for two variable or two or more variable you can consider in your model, but we have to consider one as a dependent variable and one or more as independent variable. Okay, and both variable, suppose you are using the simple regressions model, so both variables should be in metric variable or should be in interval variable or should be ratio form. Okay, you can use the simple regression or linear regression model. Okay, so you can use this. For doing analysis this, you need the dependent variable, which the value of the variable is explained by the independent variable, and at least one independent variable should be there in your model. This is a very important. And a data type, already I told you the data type. It is required if you are this is the simple regression model or linear regression model. So you have to use only the ratio or intervals. Okay. So this is the simple regression. Suppose X is a explain the Y, or this is the simple regression. Simple regression means only one independent and one dependent variable in the model. Okay. Multiple regression means the one dependent variable, that is Y, and more than one independent variable in the model. Okay, that is called the multiple regression. It would be more than one variable. It may be 2, it may be 3, it may be 5, 6, 7, whatever the variable you are keeping as. So like that. So we have to keep. Okay, so this is what the simple and multiple regressions. Okay, so when we are going to calculate this, this is the simple regression equations. The y is equal to alpha plus bx. Okay, so y is the predicted variable. Okay, so x is the predictor variable. Okay, so means the value of y is dependent on the x variable. Suppose 1% change in the x, some percentage will change in y. So what percentage change will y? This is called the beta or slope percentage will change the y. Suppose 1% change in the x, so beta percentage will change in the y, and a or this is the alpha is called actually the constant or intercept. If you come to here, you will come to know this. This is the slope. Suppose 1% change. Suppose x is, so beta slope will change. This is called the straight line, the linear trend line, and this is the intercept. This is the constant. Okay, the over time. Okay, so this is the constant. So this is the error term. Okay, this is the error term. So we are writing the alpha plus bx plus e. So this is what the error term. Okay, so if you'll come to here, you can this is the residuals. Okay, it is nothing but the error, and this is the predicted. Okay, so it's a linear straight line. So if you there are the basic method to calculate this the regressions. That we are using the method of least squares. Okay, technique. Okay, we have graphically or algebra method we can apply for calculating the regression, simple regressions. Okay, so we will go to the SPSS, how to run the regressions, and how to interpret their results, and what kind of variable we require for this analysis. Okay, let us go and we'll do it here. So here, when we'll come to the regressions, here the linear relationship is there. Okay, so I'm showing you another time. Here the analysis, here regressions, here linear. Then come to here the dependent variable, independent variable. Okay, so here what you have to do, you have to select the dependent variable. Okay, so which variable is predicted by the independent variable, or value of the dependent variable is depend upon the independent variable. So here, can you tell me we'll take the sales and advertisement. Can you tell me which variable is independent, which variable is dependent?
Sales depends on advertisement.
Sales is a depend on advertisement. Okay, so we can consider the sales. So somebody may say that how do I know a particular variable is independent and a particular variable is dependent? That is also very challenging for the researcher. Unless until understand the theory, you cannot identify. There are some other technique also, if you apply, you can also identify which variable is dependent and independent, like the Granger causality test and some other advanced technique also you can apply to understand, or we can apply sometimes our logic and understanding to identify the dependent and independent variable. For let us take here the advertisement as a independent, sales as a dependent. And also we have understand that there is some strong relationship between these two variables. Okay, so then we have taken one independent and one dependent. Okay, so then if you want to do it the estimate and model fit, you can keep, and other descriptives if you want you can keep, otherwise it is not necessary. Then if you go to the options, if you want to make the test at 95% level, that is not required. Let us go to the OK. Let us draw our results. Okay, so now we have got the outcomes here. So three important outcomes we have got. Okay, when we run the regressions, these three basic important outcome we'll get. First one, we'll get the summary table or a summary of the model. This is the ANOVA and this is the coefficient. Okay, the regressions coefficient, the beta coefficient value. Okay, so when we'll come to the model here, the R square. Okay, we will get the R value. We have already tested there, and we find out that the 0.780 when we have run this correlations. And this is the R square, and this is the adjusted R square. This is the ANOVA table, what we analysis of variance, and here correlation, sorry, coefficient. So when we come to here, the model summary. So R square is very important. It is nothing but the determinant of regressions, or determinant of regression means what extent the advertisement influence the sales, or how much sales is determined by the advertisement. It is nothing but the 60%. Okay, so 60%. So as we are considering only the one variable, so it is 60%. Okay, so adjusted R square, always it should be less than R square, means if you add some additional variable, there would be some improvement. Okay, so sometimes what happens, some whatever the independent variable we are considering in our model, that may not be sufficient to explain the sales, or only the advertisement cannot explain the sales. There are some other variable also explain the sales. So due to that, we have to also sometimes consider the adjusted R squares. Then if you want to know about the ANOVA, so it is a talk about the model fit. So whatever the variable we have considered in our model, whether giving a good model or not. Okay, that is we can test it with the analysis of variance. If it is significant, then we can say it is a good model. If it is insignificant, it is not a good model. There is a problem with the model, or there may not whatever the taken as an independent variable to explain the dependent, it is sometimes maybe wrong due to not a good model, or our model that may not be reliable. Okay, so here the ANOVA is actually less than 0.05. Okay, the significant value means it is indicate that which variables we are considered in our model, it is good fit. Okay, then another thing is the coefficient. This coefficient we have to understand here. We have understand here the coefficient. We have that standardized and unstandardized. We have to always look at the unstandardized value. This is the constant. We have written y is equal to alpha plus bx. So here the beta, that is the unstandardized beta, it is positive, means the advertisement is having the positive impact on the sales. Okay, so if 1% change in the advertisement, 0.50 will change in sales. And whether the advertisement significantly influence on sales or not, so you have to check here significant value here, 0.008, which is less than 0.05. So you can consider the advertisement significantly influence the sales. So this is the way you have to tell if it is a simple regression. This is a simple regression, what we taught. Any doubt, any clarification about this? Am I right?
Yes, sir. Clear, sir. Clear, sir.
Okay, so let us take another example, so that it is a very easy example everybody might have some experience. So let us take another example, regression, linear. Then we will remove this two variable. We'll take the another variable, the investment. Investment will take as a dependent variable. Okay, independent we will take as a income. Income and savings, because the income and the savings, okay, it's a explain our investment. Our investment completely depend upon how much I have earned and how much I am savings. Okay, so that may be explained better the investment, unless if you take only the income explain the investment, that may not predict accurately, or that may not predict the 100%. There are some other variable may be explained. So I have considered the two independent variable, that is called actually the multiple regressions. Okay, so then I'm not changing anything, so just I'll put okay. So let us go to this. If we'll come to here, so r square is 0.599 means means the investment is explained by investment is explained by savings and incomes with 59%, near about 60%. Okay, so if you look at there, the ANOVA is showing that it is a good model, because the because whatever the variable we are consider in our model, so it is predicting accurately. Okay, then coefficient table, if you come to the coefficient, the income and savings, so both variables are actually significant. If you look at that significant value and their beta value, and look at their sign, it is a positive, means the income and savings explain the investment positively. Okay, means the investment is explained by the income and the savings positively with this percentage, 0.29% with the incomes. Okay, and the savings explain the investment 58%. Okay, significantly. So this is the way you have to make interpretations. Okay, this is all about the test. You can use the parametric test for your analysis. So if you have any doubt, any clarifications, you can ask. Any doubt? Any doubt, any clarifications?
Sir,
I'll give you 5 to 10 minutes.
Yes, sir. Sir, the R square you explained now, sir, for previous case and this case.
Yes.
That can you explain again, sir, 59%.
It is a yes, I'll talk about this. So investment is explained by income and savings together with 59%, means the investment is explained by savings and incomes 59% or 60%. And 40% is explained, and another 40% is also there now. Another 40% is explained by the other predictor, which are not being included in your model. Am I right? Only 60% is explained by the income and savings to the investment. Am I right? Are you getting?
Yes,
this
sir.
is called the determinant of regressions. Okay. Anybody else? Any questions? Okay, over. Hello, ma'am. Lelin sir. So this is all about the session today. Yes.
Yes, sir. Subhendu sir, can you go to the dimension reduction for few minutes?
Diamonds. Okay. So
yes,
shall I go with that? So
yes,
if I'll okay, if I'll take another 10 minutes, no problem. Can I continue?
Yes, sir. We will continue. We will complete 8:30 or
Okay.
8:25.
Okay. Then yes. I'm going for the factor analysis, dimension reductions. So no problem. Yes. If you are
Dimension
interested, then I can go for this because okay, no problem. Okay, so let us go to the.
Sir, I have a doubt here, sir.
Yes.
Here in output.
Ma'am, 1 minute, ma'am. 1 minute. Just okay, dimension reduction is very important topic. Let us complete. It will take literally 10 minutes or less than 10 minutes. He will complete. Then you should ask question now because dimension is very important. As Sven sir also knows that it will help you. Then you can go for a question. No problem. No sure. Few minutes. Give me 2 to 5 minutes. Yeah. Thank you. Then you may have a question.
Okay. So thank you. So another is a very important technique, which is consider the multivariate data analysis, that is the factor analysis, or it is called the exploratory factor analysis. So sometimes what happen, we have so many statements or so many questions in our questionnaires. Okay, suppose we are asking you to find out the awareness level of a particular aspect or awareness about a stock market. So you cannot predict the awareness by asking only the one question. You have to consider the n number of questions. Somebody may consider 5 questions, somebody take 10 questions, somebody take 25 questions, somebody take 50 questions. Am I right? So those were considering the large number of questions for predicting or explaining the awareness. So it is very difficult for them to make the analysis or considering the 50 statements for the analysis. Okay, so how they will reduce that variables. Okay, so but if you consider the n number of variables to explain a particular variable, that is good for the researcher, and you also get a reliable result. Some researchers they may say that no, if you consider more statements, it creates more confusion. Not like that. If you consider more statement to identify or predicting a particular variable, it is good. For a research, you will get the reliable result, and there are some kind of statistical techniques or multivariate techniques to help you to make such kind of data analysis if you have a more number of variable in your particular aspect. Okay, so today we are going to talk about that the factor analysis. So let me open my PPT here. Factor analysis. So in factor analysis, so basically we will use the factor analysis in our research to minimize the large number of variables into the meaningful factors. Okay, for example, suppose you have 20 variables you have considered to determine the awareness of the people. Okay, that 25 variables you cannot consider for your analysis, or you cannot give the importance each and every 25 variables to make the analysis. Here you can apply the factor analysis to minimize that 25 variables into the 5 or 6 factors or 4 factors, which factor can be considered for the further analysis instead of considering the 25. These 4 factors or 5 factors will explain or represent the 25 statements. Am I right? So this is one kind of technique we can use for the analysis. So let us go with this technique. So when we will go this technique, so this technique, so our data should be interval scales data or ratio data. Generally we use the interval scales data. This technique is used to reduce the large number of variable into the few meaningful factors. Okay, that factor will be determined or will be created through the factor analysis. Okay, and this factor analysis will extract the
using only 5 variables. Is it okay, sir?
Yes, sometimes it is okay, but 5 variable you can use the factor analysis and you can minimize into one or sorry, not one, 2, 3 factor you can convert. But if it is a 5 variables, we need to understand what kind of statistical tools you suppose you are going to use. Okay, suppose you will use independent sample t-test or ANOVA, so it may be run 5 times. Okay, so if you use the factor analysis, if you will find out 2 meaningful factor, you will run only the ANOVA for the two times. Am I right?
Sir, I would like to apply this factor analysis. What are all the factors which influence the sales? So I am using price, package, color, and 3 more factors.
Yes, yes.
So I am using the entire 6 variables. Can I use factor analysis, sir?
You can use, but we have to understand that what kind of statements you are keeping under this. Okay.
That
So,
is I am telling you, what are the factors influence the sales?
influence.
Price strategy, color, package, on timing, delivery. So like that, I am
Means,
taking 7
deliver. No,
factors.
ma'am. You say the delivery. How to determine the delivery? It may be the time. It may be the place. It may be because each factor they may have the different indicators to determine the delivery. Delivery, if you having the own observed variable, it is not required on the factor analysis. You can go with the direct.
So
Instead of
on-time delivery, that is also very important. That is also one of the factor influence the sales.
Ma'am, sorry saying that construct and factors. You are telling about the items. That's the difference between the items and the factors are construct.
No,
Okay.
even it is not a construct also, you can make like the individual factor also you can consider, but we need to understand that if there is any indicators to measure that particular factors, if it is there, then you can use this factor analysis. It is not mean that only the construct we can use it. Okay, so we can use if it is a single variable, it is not required on this factor analysis. If a delivery is only the one single variable, then you can use directly. It is not required to use the factor. That's why the delivery, what is the meaning of delivery? It is the time, speed, locations. Am I right? There are many ways you can determine this delivery. Am I right?
Yes, sir. Yes, sir.
Okay, yes. Okay, so this is what we can make, and the assumptions. So assumptions is very important in the factor analysis. One is the outlier. Okay, when you will make the factor analysis, we have to detect the outlier. If it is there, then you have to remove from your data set. That is very most important. Okay, because unwanted data may be there, on relevant data also would be there in our data set. And another is the sample size. Okay, so sample size should be always greater than your factors. How many factors going to extract from your variables? Actually, we have to look at their sample size. The sample size always should be the more than the factors. And another thing is, as we are using the linear model, general linear model, so we have to satisfy with the multicollinearity issues. Means there should not be any multicollinearity issue among the variables which you are considering for the factor analysis. Okay, there should not be highly correlated. It should be less correlations. That is what is needed, and also it is required the linearity. And when we are using this factor analysis, so we have to use the extraction method. Which method you are going to use to extract the factors? Okay, so there may be the principal component matrix, which is very popular, and that maybe used mostly. It is used this method, which can be extract the maximum variance from the variables and put into the first factor, and consequently it will remove the variance from the first factor. Then it will auto extract the second factor. It follow the same practice to get the all factor from the data. Okay, so common factor analysis also there. This is also another extraction factor, but it is rarely used because it won't consider the actually the variance of each variables. Okay, it is considered only the common variance from the data. Okay, so due to that, we are here mostly use this principal component matrix because it extract the variance of each variable, how which are being included in your model for the factor analysis. Okay, so rotation matrix will use the Varimax method for this is also another method to rotations. Okay, to find out the how the variables will associated with the particular factors. Okay, so generally we use the Varimax here, and some important outcomes which are needed. Okay, to run this factor analysis. Okay, so one is the KMO. Measure of the sampling adequacy, whether whatever the samples you are considering for your data analysis, whether it is adequate or not. That is also very important. It may be sometimes it may not adequate for determining the factors. So for that we have to use some threshold value like the 50%, okay, minimum. And ballot test also, it is a talk about the correlation matrix, whether the correlation are identical or not, means each variable whether it's uncorrelated or not. So if it is significant, the ballot test, it is acceptable for the factor analysis. Then commonality is also very important because we need to understand what is the capacity or what is the each variable variance. Whether it is explained by the factor or not, at what percentage of each variable is explained by the factor. So that is very important. So this is three important parameter we will look at while we will go for the factor analysis. Okay, so let us go to the factor analysis so that we can understand. Here I have taken the another different variables. So which variables I have considered here, factor analysis. So I have considered some variables to understand about the stock splits. Okay, stock splits actually one kind of announcement made by the company. Okay, company. So I wanted to know the who are the investors. Okay, whether they are what is their opinion about the stock splits. What is their opinion about the stock splits? So I have taken this stock splits. I have to open. I didn't open the right PPT. This one only. Yes. Okay. So I have check what are these variables. Yes, we have here stock splits. Okay. So we have stock splits. Okay. So we have how many variables of stock splits? So I'll go to the variable view, then we will come to know how many is. So here in the last, we have this stock splits. Okay. So stock splits. So these are the stock splits. Let me select just what I'll take it. Please give me some time. So I will delete some variables so that I have deleted some. Clear all this variable. So now you come to here. So here I have those perceptions of the stock splits. Okay, so we have 18 variables. Okay, 18 variables I have considered to understand the investors' perceptions about the stock splits. And this 18 variable I cannot take for the analysis. It is very difficult. It is very challenging for me without factor analysis. It is very difficult to measure the perceptions in my study by considering each and every variables. Okay, so instead of that, I will consider all this variable and run the factor analysis to find out the some meaningful factor which can be considered for the further analysis, and that factor will represent all these 18 variables. Okay, so we will run this. Let us go to the analyze, then dimensions reductions. Okay, here so we have factor analysis. So after this, so we have here 18 variables. You have to select all variables. Okay, after selecting this, then you have to go to the descriptive. So you will get the descriptive statistics. If you want to understand about the descriptive statistics with each variables, you can click it, but I won't record. And the initial solutions. So what is the before rotations? Okay, before extractions. So what is the initial solutions value? If you want, you can put it here, but I can put it here. And another is the KMO and a bullet test. So this is very important because it will talk about the sample adequacy. Okay, and whether our correlation matrix is unique or not. So in that, because it is in minimum requirement for running the factor analysis. Okay, so then we have to go to the extractions. So extractions, we have the various method, but here we have to use the general the principal component matrix. Okay, we have selected it. Then here another is the extractions will be happened maybe the based upon the two aspect. One is the eigenvalue, because it can be extracted based upon the eigenvalue, those variables which are those factors which are having the eigenvalue 1. So we can consider as a one factor. So otherwise it won't be considered. Okay, so otherwise there is another. Suppose you wanted to know, or some theory says that this perception of the stock splits is explained by only the 4 factors. There is a customize here. You can put here 4 factor. It automatically it will come 4 factor. You will put 5 factors. It will come automatically 5 factors. It is customized. You can, if you know the theory, if you know the some past study, so they have taken the same variable. So you can customize here. Okay, you can do it, but I'm going with the eigenvalues. Okay, so let us go with this. Then rotations. So rotations, I told you, we put the Verimax. Okay, then go to the continue. Then if you want to save the score, what are the factors created? Okay, that score, if you want to save for each factors, you can put as a save as. You can get it. Well, let us save. We can save as the regressions. There are the different method for a score, getting the score. We can predicted value you can get through these regressions if you want. Then continue. Then another option is there here. Sort by size. Okay, sorted by size, and suppress a small coefficient. Here you have to click here. This is 2. Then here you have to put as a 40%. Some study they consider 50% of correlation. This is nothing but the factor loading, the factor loading between the variables and factors. So we are sorting which variables which are having the below 40%. We are not considering into the model, or we are not considering into that particular factor. So minimum 40%. Some study may be considered 50%, or you can keep the 10% also, no problem. So I'm considering, then put OK. So now we'll get the value here. You see here, KMO, first you will get this outcomes, KMO bullet test. So KMO bullet test, the value, if you look at this, 0.759, it is more than 50%. So means the there is the samples are adequate. What are the samples we are considering for the analysis? It is adequate for the factor analysis. Okay, so bullet test also significant, means no problem for running this the factor analysis. So we will get the meaningful factors by running the factor analysis. So come to the commonalities. So proportion of each variable is explained by the explained by the factors, okay, extracted factors. Okay, so this is what if the higher the value, it is good because that particular variable will be contributing to the factors that much percentage. Okay, so it is good, or this particular variable can be a factor to with this percentage. Okay, so this is what we consider. And if you come to here, this table is very important to us. Okay, so this table is very important to us. Now I will take this table. This table is not visible to me. Yes, this table, if you look at this eigenvalue, okay, initial eigenvalue, so 5 factors, okay, 5 factors, and extraction sum of square loading, rotation sum of square loading. So this one we have to look at, and their cumulative rotated sum of square loading is 64%, means the 5 factors is explained by 64. Okay, means the total variance is explained by the 5 factor is 64%. Okay, so means, so what are the 18 variable we are considering, and that 18 variable going to be converted into the 5 meaningful factors, which is explained by the 64% variance. Okay, so means the total variance is explained with the 5 factors. It is enough for the research. It is sufficient. So minimum 60% is required. So 64% is a good sign. So we can consider the 5 factors for the analysis instead of using the 18 factors. Then component matrix. This is the without rotations, without rotations. So this is our the component. This is the first component, first factor, second, third, fourth, fifth factors. Fifth factors, you go to the rotation matrix. How it is looking like? We will go to here. This table is very important to us. This table is very important to us. This table is very important to us. So if you look at this table, the first factors, okay, so first factors, so these are the statement coming under the factor. This is nothing but the factor loadings, means the stock splits are fashionable with the first factors. The means this is the correlations is having the 0.822. Similarly, the stock splits improve the image of the company 0.79 with the first factor. So these statement coming under the first factor, these statement are coming on the second factors. So similarly, we are, if you look at this, so this many statement are coming under the third factors, and some of the variables are coming under these factors, and some of the variables you will find out coming under those both factors, so second factor and this factor. So in that case, so you can either you can remove, if there is a low factor loading, you can remove, then you have to check how your model is, whether the factor loading is improved or not. If it is not, then you can keep where it is applicable. Okay, so based upon their factor loading, somebody may say that it is a highly correlated, this stock splits make it easier. It's highly correlated with the second factor rather than the last factor, fifth factor. So we can keep here. It is not a problem, but this is the way you can make the factorizations. Okay, then after that, you can come to our output, our variable view, so that we can find out with what are the factor we have created, whether we can create that value or not. So we can check here. So it has not been saved, this variable. Okay, so no issue. So this is, I think this one. Yes, here, yes, this variable. You see here, if you come to here, I'll take to here. You see here, which factors we have created, 5 factors, that value is here. That value is here. 1, 2, 3, 4, 5. This factor, 4 factor value, you can consider instead of taking the 18 variables. This 5 factor is enough for your analysis to understand the perception of the investors about the stock splits. And this 5 factors can be considered for the further analysis or advanced analysis. Okay, so this is the way you can make. Somebody says this score is actually standardized score. Somebody says, no, I do not want to take this factors score. I will consider the original value. You can consider the original value by taking the average value of a particular. Suppose factor 1 coming under the how many variables. For example, I'll tell you how do you calculate this. You can take the average value. Suppose here the first factor coming under how many variables? 4, 5 variables. You take the average value of this, where the original value, you have the stocks which are fashionable, you go to the original value, make the average, make the total and divided by 5, you will get the average value. That value you can consider as the first factor. Similarly, second factor you have to calculate for the 5 factor. This is all about the factor analysis. Okay, any doubt, any clarifications about this? Hello? Any clarifications?
Dear participants, if you have any queries regarding the
factor analysis or any doubts, clarifications, you can ask me.
Sir, regarding that values, if it comes 0.3, 0.2 or 0.4, less than 0.4, can be removed so that we can improvise from, sir.
That's why I have put there in factor analysis. I have put sorted by 0.40.
Yes, sir.
Yes, due to this, if will not keep, then it would come here. Am I right?
Yes.
That's why it is if we'll keep there, then it will come like this. If you want to keep 10%, then they may consider the factor which are having the like below 40%, it would be reflected here. 10% means those who are below 10% factor loading, it won't be reflected here. Okay,
so,
it will keep
so
that.
We put that 40%. So more than 4 only it will come here, no, sir?
Yes.
Understood, sir. Thank you.
If it is less, it won't come.
Yes.
It won't come.
Thank you.
You can also verify here. Is there any variable here 40%, below 40%?
No, sir.
No. Okay.
Yes.
Here sometimes somebody may say that, sir, here factor loading is very low. Can I delete this item from my study? It is possible. You can delete and you have to run after that. And you check whether there is an improvement. If there is an improvement of our factor loading, you can remove this. Am I right? Because this may be having some multicollinearity. So if you remove, you can get a better model. But the thing is that you have to check how this statement is important for your construct. That is very important. Am I right? So if it is not important and you have checked this is a low factor loadings or low correlations with the factor, then you can remove it.
Yes. Thank you, sir.
Sir, I have a doubt here.
Yes.
Usually in the output, certain outputs will come as double star. Say for example, in correlation also, certain output will come with the single star. Certain items without even star, that output is being displayed. What is your viewpoint on this, sir? Should we take double star only as
no, it is
eligible or value?
Yes, it is a star means I think it is a which short term you are using. It may be the 5%. It is a triple star means it is a significant and a 99% level of confidence. It is double star means it is a significant at 95% level of confidence. Am I clear, ma'am?
Very clear explanation, sir. Dear participant, if you have any question, please.
Now open to all, if anyone can ask the questions.
You can ask any questions, and also I'm writing here my number and my mail ID. If you have any question, also you can ask.
Yes.
My mobile. Is it visible?
Yes, sir. It's visible, sir.
People like 23 phone number and my mail ID. You can reach to my mobile. Subhendu @gmail.com. Is it visible? My mobile
Yes,
number
sir.
and my
Yes.
mail ID. You have
Yes,
any
sir.
doubt,
Visible.
any clarification? You can ask me now itself. No. And also any feedback for my future improvement? Any feedback?
Sir, no question, sir. You already took the session very lively and practically. So from my side, there won't be any questions, sir. I want to congratulate and share my heartfelt thanks to you for took the session very lively and practically. Hats off to you, sir. Thank you very much.
Thank you so much. Thank you.
Yeah,
Anybody
dear
else?
participants, yes. Dr. Subhendu Kumar sir is my senior. When I was approached to conduct to resource person now to our workshop, he accepted immediately. And I also asked so many topics to explain, but he said that Lenin, it will take much time. I said, senior, take how much time you want, but comprise and give crispy or very small manner that 1 hour, 1.5 hours, that all the person or participants should get some ideas. That's what we will insist. And that 1 hour, 1.5 hour or 2 hours, you should have covered all the things like that. I insist. That way he pushed all the things. He also said that Lenin, if I'm going for ANOVA family, it will take much time because it's a big thing. And he covered all the things. Just I want to thank Dr. Subhendu Kumar for accepting my offer and came here for that workshop. And he made that workshops very well, and hope that you people got some more input from his presentation. Now I'm requesting if any have any feedback or if you have any clarification, just to go on. We will also complete. Actually, if it is goes more than 10 minutes or 20 minutes, it's literally covers 3 hours. But we are not felt that it's a 3 hours. Really, thank you, Dr. Subhendu Kumar.
Thank you, Professor Lenin, giving this opportunity. And if you have any doubt, participant, you can share your view, your opinion, your feedback, your questions, so that we can make future improvement.
Yes. Over to Dita. Dita.
Thank you, sir, for an enlightening and enriching session. We are truly grateful for the knowledge you have shared. We are the fortunate to have an opportunity to learn from you. On behalf of everyone here, a big thank you for the wonderful session. Now, let's move forward with a formal expression of thanks in the vote of thanks. Ladies and gentlemen, I am here with a profound sense of gratitude as we bring the curtains down on today's insightful session on analysis and presentation of data using SPSS with our esteemed speaker, Dr. Subhendra Kumar Pratap. First and foremost, let me express our sincere thanks to Dr. Subhendra Kumar for his illuminating presentation. His expertise has undoubtedly deepened our understanding of data analysis, leaving us with valuable insights to carry forward in our academic endeavors. I would also like to extend my appreciation to each one of you for your active participation, thoughtful questions, and a vibrant energy you brought to today's session. Your engagement has been cornerstones for this enriching experience. As we reflect on knowledge gained and look forward to the remaining days of faculty development program, let's carry the inspiration from today's session into our academic pursuits. Thank you to all who have contributed to making it today memorable and insightful experience. Thank you.
Thank you, Professor Lenin and your groups giving me this opportunity, a wonderful opportunity and a good
Thank you, sir.
experience.
Thank you.
Thank you so much.
Yes, thank you, senior.
Thank you, sir.
Thank you. Thank you. So
Thank you,
shall
sir.
I leave?
Our heartful thanks.
Thank you.
Yes,
Shall
sir.
I
Yes, sir.
leave?
Yes, sir.
You can
Thank you.
leave.
Sir.
Thank you.
Yes,
Sir.
sir. Yes, sir. Yes, sir. As dear participant, the link will be available for another 5 minutes.
Solomon sir.
Yes, sir. Yes, sir.
Sir, thank you.
Yes, sir. Welcome, sir. Welcome, sir.
Thank you. That all organizers, just I want to thank you for bringing a wonderful resource person. Wish you expecting the same. Wish you expecting the same. And special thanks to Lenin sir.
Yes, sir. Welcome, sir.
Thank you. Thank you. Thank you.
Welcome, sir.